Good afternoon, everyone. It's my pleasure to be here today with all of you during this AlterCOP 24. So today we're going to be talking about batteries and how we can enable resilient energy systems. My name is Pierre. I'm with Blunomy, a company that does strategy consulting in the space of energy transition, and I'm joined by 4 friends, colleagues, and professionals in the battery, energy, and renewable as well sector in Singapore and Southeast Asia. So we've got Achal Sondhi from Aquila, who is the Chief Investment Officer of Aquila. Aquila is a renewable energy developer that installs solar, wind, and also batteries in the region and globally. And prior to that, Achal was part of Fluence, one of the largest equipment manufacturer and integrator on batteries. And he was also part of IES even before that. We've got with us Romain Migne, who has been with EDF for the past 20 years almost. He has held position in Europe, in the UK and France, and now in Singapore. And he oversees the activities around battery development and look particularly at Japan, who is a very hot market at the moment. I think Achal also looks at Japan among other things. We can talk about that a bit later. Dr. Chiam, who is one of the founding director of the Singapore Battery Consortium, if I get it right, and he's been very active in the Singapore battery space in the past decades. And we've got with us also Lionel, who is the head of Marine Solution at Hegemonic Power, who is a designer of energy solutions as well. Prior to that, you've also been in the space of batteries, probably more on a designing, manufacturing, and technical aspect as well. You're part of some of the technical committees. So very diverse but expert panel with me today on a fascinating topic that I've been covering myself for the past 10 years as well. So maybe to start with, and I want maybe before we start, some housekeeping rules. There is a Q&A program with the code on the top right corner over there that you can scan. Feel free to share the questions as we talk, especially if there's a topic you want to or you want to dig into. We will respond to the questions towards the end. So to start with, maybe I would like to do a first round table to get a bit your perspective. Maybe share with the audience what you're doing with batteries. I think batteries is a very vast topic. You could do design, manufacturing, you could install, you could do project development. So probably explain a bit the perspective you're looking at that, and then explain from your perspective what are the main challenges and opportunities that you see for the development of batteries in Southeast Asia, and maybe we can talk about APAC as well, more broadly. Achal, you want to start?
No, thanks for that really nice introduction. So hopefully this mic's on properly. And as Pierre introduced, I'm Achal. I'm part of Aquila Capital. We do develop solar, wind, and battery storage projects across, I guess, North Asia, Australia, and New Zealand. We're not very focused on Southeast Asia at the moment. And essentially we're doing utility scale. So we don't do any of the battery that's smaller than 20, 30 megawatts. The idea is to support the grid at a utility level with the batteries that we're looking at. And our main focus is to develop them from ground up. So even really early stage grid connection and then building up the battery from greenfield. There are also opportunities where we're looking at batteries that we would acquire that are partially developed and then taking them all the way through construction and owning them and operating them. And as Pierre mentioned, so my previous outfit, I was with Fluence, and for me, that was 4 years of trying to push these markets to kind of acquire batteries and adopt the need of batteries. And I further kind of taken that step with Aquila, where I say, okay, the funding source is needed. Now, maybe 4 years ago, policy wasn't there, the idea of batteries weren't there. Even the integrated solutions weren't tested, and they reached the gigawatt scale now, but at that time, even getting a 10 megawatt battery was actually fabulous. So I've taken the next step in an organization where I believe I can actually provide the development capital and the risk capital to actually invest in projects. And I think that's where the one of the larger gating items is. It's people taking a view on the market and saying, let's develop a battery for 3 years later, but not having a very clear view on the revenue that you could achieve. And everyone will say, oh, we need a PPA, we need a fit market, we need some sort of utility intervention to say, we'll give you a long-term PPA, build a battery, and life will be easy. That's not just going to happen anymore. It's going to be up to kind of investors, developers, and the whole ecosystem to say, we need batteries to support the grid. And which way they support the grid today will be different from how they support the grid 10 years from now. And trying to take that view, only certain risk-minded IPPs can actually take. So that's why I changed outfit to kind of influence it from that direction. In Southeast Asia, if I was to talk about one of the biggest challenges, I think the biggest problem is it's unfortunate that there's no top-down support of battery storage. It's still being adopted as, oh, do we need battery storage or not? And if it's very hard to have it come up from private institutions alone. It needs a bit of a top-down approach, and that's kind of missing from most of the Southeast Asia markets. So the minute someone puts a target or some policymaker says, okay, we want to have batteries, how do we get there in 5 years? Things will move. But without that, it's very hard for people to stick their neck out and say, okay, I'm happy to connect this asset to the grid. I'm not sure what it'll do, but I'm happy to try it out. So I think that's the biggest challenge we have for Southeast Asia. I'll pause there for now and give others a chance.
Hi everyone, very glad to be here. So Romain from EDF. I'm in charge of the technical activities for the international division at APAC level. So just a brief word on EDF. So we are project developer, but we have, I would say, a specificity in the sense that we are a state-owned utility, so back home in France, where we are doing basically generation, transmission, distribution, and retail as well. And in terms of, I would say, storage assets, that's something that we have been investigating for literally like several decades, because we started storage a long time ago, like in the late 60s, early 70s, when we started to build pump storage, where basically, which is still up to now, the vast majority, like maybe more than 60-ish% of the storage in the world from at the grid scale level is pump storage. But of course, we've been looking at batteries and lithium-ion specifically for the past, I would say, 15 years, really seriously. So right now we have a pipe of around 1.9 gigawatts of batteries worldwide, mostly in the US, where the market, I would say, is highly dynamic. I fully subscribe as well to what Achal just shared, in the sense that you need to have a view to give incentives to developers for batteries. Fully agree that the golden age of, let's say, PPA tolling agreement might be, behind us, and looking at revenues coming from market and merchant exposed, that's probably going to be like the big trend for the next decade, probably in the mature market. And in terms of challenge or opportunities for storage in Southeast Asia, I would say that there is two segments, grid scale and off-grid. Off-grid, that's going to be a hot topic as well for structurally countries where you have a lot of islands, where you can't really like develop like transmission grid like all around the domestic land. Talking about like the Philippines, Indonesia particularly. So there is definitely a room for storage in Indonesia on the off-grid side. And grid scale side, definitely huge potential in the area. Just looking, for instance, at Singapore, everything that has been launched by the energy regulator here, EMA, which is to import up to 6 gigawatts of renewable energy by 2035. This will come with a huge amount of storage because the requirement is to have renewables, but non-intermittent renewables. So you are looking at tens of gigawatt hour of batteries that will be installed in the neighboring country to achieve those imports in Singapore. So definitely a very dynamic world.
Hello. Hi. So my name is Yang. So I'm from the Singapore Battery Consortium. Just to mention, I also have sort of a day job at A-STAR. So A-STAR is an agency for science, tech, and research. So myself, I'm in the materials field. So we look at battery materials, and we look at materials to deal with, for example, battery pack as well. So just to mention, the Battery Consortium, we just turned 5 years old. It was started in 2019. This was funded basically through our National Research Foundation. So the consortium itself now, we have about 80 industry members. And because it's funded through the NRF, a lot of our focus is on tech and innovation. So you see that our members are primarily from the product space, especially from the cells, the packs, and also in the end-of-life space. So not so much on the project basis, so more focus on, for example, innovations in the battery product space. So the consortium itself, since we started in the innovation space, maybe one good example is the recent EMA grant call in ESS Innovations. So we are lucky enough that the 2 awarded projects are both our industry members, for example. As for the challenges in Southeast Asia, from our point of view, there's maybe two segments. So one is, as mentioned, there's a lot of deployment challenges, but maybe I'll mention on the other one is what we see as manufacturing side of things. So manufacturing side of things for Southeast Asia, I think is an opportunity, but it's also challenging because there's a lot of entrenched players globally as well. And Southeast Asia is very nascent. It's a very, we are just starting out in looking at manufacturing of both batteries for both mobility, stationary storage as well. But I think all the countries have this ambition based on the people we talk to in Southeast Asia. So you'll see policies going to go in the direction of local content, especially when they are looking at products coming out from to be deployed in this space, because this gives us a chance to ramp up to be in part of the value chain for battery. It's still a challenge for this region to capture part of this market, but it's something that I think the Southeast Asia countries are trying to do as well.
Hi everyone, I'm Lionel from Hegemonic Power. We are a new startup in Singapore that is working on the solutioning side of the matters. So we do look at utility scale, even though that's not our major stand, but we are very much in the C&I space, commercial and industrials, and as well as mobility batteries for marine transportations. So for us, batteries are kind of used to give you power everywhere you go and every time you need it. And that's what our central goal is. But the biggest challenge to answer Pierre's question is really on the safety side. A lot of people from our customers would love to use batteries, but is always concerned about battery safety. So one of the business models that we have here is really to kind of provide the service to kind of bring the customers throughout the whole lifetime of the batteries to make sure that they are comfortable in using it and allow us to enable them to use this amazing technology that we think that can help them get their renewables to their necessary needs.
Thank you guys for this first round. I think very interesting to hear that even though we all talk about batteries, there's very different ways batteries can work. And so, Achal talked about, utility scale batteries. Romain talked about more the off-grid, and you mentioned mobility as well, and marine batteries. I think it's important to understand that, okay, batteries are a technology that enables you to store energy in the form of electricity. So you can draw power and then give it back later, so to, I guess, arbitrage in time. But the actual usage of a battery can be very different. And also by that, it means that the competition, the alternative technologies or solutions for batteries are very different. So if I take the example of the grid, right? So some utilities might want to have some batteries to be able to better operate the grid, have more flexibility in the power system. But there are other types of storage, and I think, Romain, you know pretty well pumped hydro storage, for example. There are other technologies of storage that can help in that regard. There are also other solutions that are not storage, such as load flexibility, for example, or having other sources of generation, like what's called spinning reserve in the grid. Right? Off grid, I guess the usual competitor is the diesel genset. So if you go to an island in Indonesia, they're more likely to have a diesel genset than to have a solar and battery. Maybe in the more renewable sense, there might be biomass as a potential competitor. In the mobility, I think there's hydrogen. Hydrogen cars kind of battery cars, but still different. So there's a range of competitors, either solutions or other storage technologies that are out there for batteries, and there is a widespread range of application for batteries. So my question to you guys, and I'm actually quite interested by the more technical aspect of it, although from a project development as well, it could be interesting, is what are the key innovations that needs to be to happen so that batteries really become the go-to technology or the go-to solution? And we also need to understand that we can talk about disruptive innovation, so like a change of material or change of something, but it can also be quite progressive and gaining in efficiency and so forth. Right? So keen to get your perspective on that matter. I don't know if you want to start, Dr. Chiam or Lionel.
Yes. So yes, indeed, there's a lot of competition or alternatives that's there for battery solutions. But on the technical side, I think one thing that batteries bring to the table is speed. Is one of those things that really allows battery systems really can support many different systems because of its speed of response to any demand that you need. Typically, when it comes to surges, high-speed responses, sudden ramp-up needed for any sort of immediate power demand, batteries is one of the best solutions in the market right now to help. So, for example, even for hydrogen per se, if there's a time or any fuel cell related or even redox batteries, if there's any time needed for them to ramp up in power, this ramp-up period can be very well supported by battery systems.
So my thinking in terms of innovations on I think it depends on the application. So if we look at energy storage systems for, let's say, grid or utility scale, I think that a lot of the innovations in terms of the product itself is quite mature. I think the safety part is something that we think the authorities and the community is quite concerned about in deployment, and then cost. Cost is a very important part of.
What can we improve on cost?
and cost, it goes down to, because if you look at the cost of the system itself, the cells takes up the cost, but the margins are different across each site, and it depends on then the whether you want to, if you are looking at local content, then maybe the cost will change. How open are you to look at products from other places, and then what's the quality of the product, especially in the quality control. How willing are you to look at a difference in that?
And maybe on cost, I'm sure all of you have seen those cost curve going down, right? And use them in your business model. I don't know if the audience have seen that, but if you Google the cost of batteries, you can see that there's a trend that goes to zero in 2050. So can we believe that? It doesn't go to zero actually, right? But it reduces quite a lot. Can we actually believe that? What's the driver behind this?
Well, I was thinking maybe there will be something that I can hear. Maybe just a quick. If it goes to zero, I'll be very happy as well. I don't know, maybe, but I think the cost factor always comes with scale. So for example, even if you look at the new technology in sodium-ion batteries, in principle the materials cost is lower, but it's just not cheaper than, for example, the LFP batteries currently, because the scale is not there. So you need some time for the suppliers to react to scale to reduce the cost. That has happened for lithium-ion batteries. It has come down. But there's also the competing factor of the geopolitics side is creating maybe separate supply chains as well. And then that throws in something which may be different for different regions in the cost factor. So that is something to be wary of. Yeah.
Want to? Okay.
Just while we're talking about cost, like just a quick one on this. Yeah, indeed. I mean, I think no one saw this drop coming. I think it's highly. I'm not sure it's gonna last forever, to be honest. I mean, that's probably it won't go or decrease at the same rate for the next 5 or 10 years. probably is going to be stabilizing a bit, if not slightly increasing. Right now, like the trend behind is mostly like the electric mobility is not catching up as fast as the supply chain like foresaw. So basically, you end up having like those cells available and switching from, I would say, mobility application to grid scale and then stationary battery, which is excellent news for us, like as renewables developers. So definitely it can make like a project bankable, which was not the case like in several configuration like before. But yeah, the trend, I mean, going down to zero, I mean, I have high doubt on that, but we'll see. I mean, it's full of surprise, so it's a bit of a crystal ball, but we'll see. And getting back to the innovation of what we could expect to foster like the development of battery, of course, cost definitely, but I would say safety. You're right. That's still an issue. I mean, we've seen countless like projects in various geographies where the fire department basically is like the king of the day. Like if they don't approve or don't support your project, or if they have any doubt of fire spreading around a residential area or so on, they will kill the project, and we've seen that. So that's fire is definitely a concern, even though, to be honest, the track record is quite good. But I would say that on my side, what I would really like to see is events like denser battery. Right now in a container, you can put 5 megawatt hour. Hopefully, if we can put 7, 10 megawatt hour, that's going to be even easier. And potentially as well, having longer guarantee. Right now, you get like guarantees from OEM around, let's say, 20 years. We're starting to see suppliers that are ready to insure and guarantee the performance over 22 years. So that's quite new. And ideally, the idea would be to, I would say, synchronize those timeline of and lifetime of assets between the batteries and the renewables, which is usually more in the range of 25, 30 years. So that's the two main innovation, yeah, on my side.
I kind of concur with those. So I think the cost curve you talked about went to $60. And I think 60 to 100 is probably where we'll end up, in my guess. I don't think it's going lower than that.
That's dollar per
Kilowatt hour.
Kilowatt hour.
Whichever metric they're in, but roughly 60 to 100. So firstly and most importantly, this question comes up in every conference. And it's what's the next, because everyone's hearing sodium, redox, I don't know, many other kind of chemicals out there. And really, there's a lot of experimentation, which I encourage. So let's divide the industry into like 10 years from now and 30 years from now. For the next 10 years, lithium ion will be the prevalent solution no matter what. To get anything else commercially ready is going to take at least minimum 10 years. And as mentioned, the vehicle industry is already driving it, so the prices are going down mainly because of that as well. So you're not going to move away from them for 10 years. Good to experiment, good to figure out what's next, but that's going to be the prevalent one. It's speed, also is kind of irreplaceable, and that's where it fits in the stack right now. So in the supply stack on your power grid, there's a space for every type of technology. Maybe not coal and diesel, that's why we're here, but outside of that, there's a space for even pumped hydro, there's a space for sodium ion, there's a space for all of these, because they have different applications as put by one of my colleagues here. And so the innovation should be to improve the lithium ion kind of capability, denser, better degradation, maybe more safety standards, of course, as well. And then looking for those other technologies that adhere to other applications for longer duration, for more sustained, maybe 3 days, 4 days. And that's kind of where innovation should take us. And that's where you kind of then firm up the whole grid to be fully renewable to the extent it needs to be. Again, back to price though, I think there's so many ways the next 10 years will play out, but the next 5, my view, which is what I think, if the American government does switch off from climate, their climate policies, there's gonna be huge supply excess, which would selfishly support APAC. But that's not the right way to think, but just from a pure investment stage of an APAC person, it would help APAC because prices would go down for the APAC market. You're not competing with supply chain for America. So that's one small next 5 years thing on price, which I think would maybe be interesting to see.
Thank you. So we've done 2 questions out of the 8. We're doing great, guys. And we've used almost all our time. So there's a couple of questions from the floor, and happy to go into that. maybe the first one, is it viable to make use of battery systems in an hybrid arrangement with other energy systems such as hydrogen and ammonia?
Yes.
I will add, extremely important.
Same, definitely. I mean, I mean, if you're looking, it depends, like, it wasn't like precise, but I guess we are talking about low carbon hydrogen, low carbon ammonia. So definitely, indeed, if you want to power those kind of complex industrial assets with renewables, you need to have storage, you need to have stability, like the Haber-Bosch plant, which is converting the hydrogen into ammonia, tolerates like zero fluctuation. So if you have any outage or anything, basically your plant and your batch is ruined. So definitely, yes, you need storage for low carbon hydrogen and ammonia.
Well, it goes back to a point that I think Achal mentioned, which reminded me, one of the challenges is the long duration storage side, let's say about 100 hours. So they basically play in the different time scale for let's say lithium-ion battery storage and let's say hydrogen ammonia. They can play in different time scale. So it's not a competing factor, and you have to find a way to work with both.
Yeah. And I actually worked, I don't think if you did, Romain, but there are projects like in Australia where there are pumped hydro storage coupled with batteries, and there's also batteries that are coupled with normal hydro plants. To go back to some of the comments that were made on speed, the battery brings the speed, and I guess the hydro brings the duration and everything that goes behind it. Perfect. Can we answer so that we can see that the questions are no, we cannot. That's fine. We'll live with it. So maybe there's a question for you, Dr. Singh and Chiam, but I think it also echoes a point that Achal made at the very beginning of the conference, saying that we were missing some top-down support. Maybe we can expand a bit on that, and we talked a lot about the cost, but I guess the revenue question of batteries is very important. So is there a role that needs to be played by governments and company, and I guess not sure what companies refer to, but probably here utilities, system operators in imposing some cleaner technology and that could apply to batteries?
So I think this is quite a good question. I think the short answer for me is yes, and it's an opinion. So I think currently the space for the battery products itself, I think both grid, mobility, etc. There's not a lot of emphasis in looking at the carbon footprint, the manufacturing footprint, for example. In the battery cells itself, the CO2 emission over the life cycle is a significant part of the lifetime emission, let's say for mobility. But as a consumer, when you buy the product, you might not necessarily look at that so much. You might not even put a premium on that if you buy the product. So then if you look at clean technologies that some of the companies are trying to do, PFAS-free, dry processing, low energy, low carbon footprint of battery cells itself, a lot of the driving force might come from the regulation side, which comes from a collective desire for certain regions or countries to look at green technology in a full life cycle basis. Because if it's coming more from the consumer side, it might be, I think, challenging to get there. So I think there's definitely a role to be played by authorities or governments. Yeah.
So I would like to add a little here, as much as it's not exactly part of the topic today. The marine side of the story has even world organizations coming in to fit into that statement. So for example, the IMO, the International Maritime Organization, is going to set a carbon price in 2020 by 2026 for an international carbon price for all ports and vessels. So when that kind of things happen, member states of the IMO will have to impose that onto their vessels. And for that reason, that become one of the driving force for everyone to start looking into such alternative systems as well.
I was going to say that's amazing, but that's kind of more of a top-down signal, right? So they do have to play a role. I think everyone plays a role, but of course, let's, again, in perspective of Asia, where we have central utilities in many countries, right? So there's one utility owning a lot of generation, transmission, distribution. In those scenarios, it's even more prevalent that actually there has to be a role of government to support, because some of these utilities are supported by the government financially. So for them to make bold decisions, they need the support of policymakers. And without that, they're not going to be able to kind of deviate from what they know best. And that's why in our part of the world, it's actually even more important.
As well, I won't be very original, but yeah, definitely you need to have support from government for to foster like storage. Right now, I'm just going to give you two examples. So they are not in Southeast Asia per se, but I would say in the overall APAC region. Definitely, when you look at what India is doing to try to foster long duration storage, so not talking about batteries, but more like pump storage, they are starting to launch tenders to give, I would say, capacity payment on long term to project developers, and that's definitely the way to go. And similarly as well in Japan, this time really for batteries, the government launched last year the first tender where basically developers can apply for a capacity payment that gives long-term visibility and ease of financing as well with lenders and investors. So that's definitely something that we need to kickstart this massive deployment of long-duration storage that is needed right now for the energy transition. Yeah.
Thank you. I think we've got time for another question that was kind of asked from the floor, and I think it was touched on. It's more that the topics around the entire life cycle of the batteries, and I think I'm keen to include both the upstream, and I think if we go up to the mining sector, for example, I think that today even when I work for investors on the funding of batteries, they ask me where is the lithium coming from? Like there's nickel in there, is it being mined in Indonesia? How do we deal with this? And then on the other side of the spectrum, right, there's the battery recycle. What's the end of life circuit, if you want? So is that something that you look at when you develop projects or technologies, or do you consider that maybe do you think that there is a need for governments to be more stringent? What's going to be the impact on the projects and the development of batteries if that happens?
On my side, just a very quick one, definitely that's something that you need to look at because the whole point is to install storage to contribute to the energy transition, so you need to be consistent as well in the approach. So definitely that's something that on our side we do. We have quite stringent ENS requirements when we do the sourcing of batteries and getting to the government. Just as well, a very brand new example, getting back to Japan. So for this government tender, this year, the Japanese government is asking that all the developers who are going to submit their storage project, they will have to comply and they will have to show that the supplier is certified by the Ministry of Environment in Japan in terms of waste certification, waste removal certification, meaning that if you don't have, if you intend to use a supplier which is not certified according to this end-of-life management, you won't be able to bid and to submit. So it's definitely starting to be a hot point as well for government.
Yeah, no, I agree with that. You have to look at both perspectives. So I think the mining side of it is a highly contentious topic, because if you don't dig properly, you may actually end up purchasing batteries that are mined improperly or in really bad environments, and you don't want to be supporting something like that. And then, of course, depending on which country you're building and where it's being mined and where it's being refined, that plays a role as well. That's more political than actually commercial or environmental, but it's something to be considering. On the end of life, what at least the last 10 years I've known is some of the big suppliers, when they have MSAs with the integrators, they already have an agreed recycling plan. It's there. You just need to dig into it, understand it, and see what they're doing, what the process is, what the melting process is. Do they pick it up from the site? Do they pick it up from the nearest port? So there's small details to refine out, but actually there's a proper way that can be done as long as it's a bit more of a larger battery supplier. The problem is when you get to second tier, third tier, some of them haven't actually established a proper recycling process. So that's where sometimes the distinguishing factor between a tier 1 and tier 2 actually comes in.
So I think for the end of life, at least from Singapore's perspective, there's various sectors we look at, like collection is one. But for industrial type of batteries, or even the electric vehicle side, we don't see that as a major problem, for example. Then there's the recycling part that links to use of resources for manufacturing, the mining side. In that, for the innovation front, there's certain chemistries that is harder to extract value from. And so it becomes difficult in the recycling space to build scale and capacity for that, because you can't get financing for that, for example, I think, right? So that's something in the research side that we are working with. But there's also one more part on the carbon footprint as well in the recycling space. But the carbon footprint for recycling is not a high component. Let's say if you look at mobility side, it's not a high percentage of the total carbon emissions. It's like 5–10%. But it is still important in terms of how we can get this to be lower. So these are some of the major things that we are looking at. There's also other technologies in the space in assessing of the end-of-life battery status. What's the state of health? Can you repurpose it? How do you repurpose it? What application can you use it for? These are all things that we are working on. We as in the community here, the research community here is working on.
Yeah, and as a part of the solutions that we provide nowadays, this topic definitely comes out on the end-of-life treatment of the products that we produce. So a lot of it is dependent on who owns the battery, eventually, the ownership of the battery, and also government regulations. So for example, in Singapore, if you are a supplier for such things, it's classified as an e-waste, and then NEA will require you to actually come out with a disposal plan as well whenever you try to sell these products. So then there is also the part of repurposing. So myself have been, we did manage to do some projects in Singapore regarding repurposing, where we took electric vehicle batteries and then use it for grid storage. Works quite well, but unfortunately, it all comes back to cost. The second life batteries or the repurposed batteries are generally not as cost effective, because the processes to make sure that they are safe to use is still too expensive. And until other sources of income comes in from such things, even including the recycling as well. Once there's other sources of income that comes for such sustainability efforts, then I think it will become a lot more widespread, in my opinion.
Thank you for that. Still a lot of questions to answer, but there's two of them are on the same topic that we briefly touched on, but we can expand a bit more, is safety. So the question is, what are the new development in terms of battery safety and fire suppression? And the other one is a bit more technical and cite a number of frameworks from the IEC, for example. And the question is more like, what are the most promising framework or standards we can look into in terms of appraising the safety cred of a battery system? And probably also for the less technical person in the audience, explaining probably why there's a safety issue or a fire can start. I mean, there's been some fires starting in batteries in Australia. Why is it happening, and why do we need to look into that?
I'll try to answer this. Maybe the first two questions first. I think in terms of putting out the fire, the current literature still points to the data that the water is the best way to put out battery fire. So battery fire is inherently a little bit different from, let's say, chemicals or fuel fire. The temperature is a little bit higher, you have jet fires, the gas emission is different. But the other things that's different is the thermal runaway that was mentioned, that in itself the battery has the so-called the triangle of the fire, that it can self-ignite, it can self-propagate. So water potentially takes care of all three. But in the innovation space, there's variants of water. So for example, water mist is one of them. There's additives you can put in the water. There's surfactants you can put in the water. You can look at foam type of technology, which is also a variant of water. So in terms of that, I would say water is still the best, but there's a lot of variance in maybe how you use the water to reduce the amount of water used, to reduce the time you need to really put out the fire. Then the second question on the standards. So again, standards, I look at it in two ways. First, there's a product standards. In product standards, there's many different international standards that you can, some of this are cited here. UL 1973, 62133, 62619, etc. There's many international product standards. And I think they are all good. They are baseline system. They are slightly different, but they are baseline system to look at the safety testing required for product qualification. But then deployment is different. Deployment looks at your regulatory body. What do they dictate is the minimum requirement, what your QP's submission requirements is, and how the authorities certify or allow for certain deployment. What's your fire escape plan? So that goes away from the product. It goes to what is your mitigation, what is the system level framework or things in place. Yeah.
Just maybe to share on the point of, let's say, what's the best fire mitigation technique that you have if fire happens during operation. On our side, basically, we have a very simple rule, which is basically if any of the container catches fire, we'll leave it burn. That's as simple as that. Usually that's the safest. So basically it's safe by design. So you make sure that you have enough distance, enough, I don't know, firewall between your container and so on. But that's really like our design philosophy. So that's one, because the issue, if you try to put some very elaborated water system, the issue is that if you try to extinguish the fire with your water, basically, you will have to be very careful at how to handle the water that will then be contaminated, and actually it can lead actually to worse damage than just letting the container burn. So that's one of the, I would say, key learnings that we have from our let's say a decade-long operation of batteries. And in terms of fire safety, so standard-wise as well, UL and IEC, they remain, let's say, the one that we put in our specification, the one that most of the, I would say, tier one supplier comply with. And in terms of, let's say, fire safety, in terms of innovation, what we would love to see, and it goes back as well to my wish on the Christmas list of having denser technology, more megawatt hour per unit of surface. If we could start to see regulation or technology that are, I would say, reliable enough from a fire perspective, so that we can stack container, so that we can use it as well, like not only on a 2-dimension, but as well 3-dimensional like perspective, that will help us a lot. Yeah.
Thank you. We've got 3 minutes left, so maybe just keen to share with you some of the 3 key points I've noted of the discussion. So that you can go back with that. Maybe the first one I've noticed is that batteries are one solution among others, and that there is a place for every solution in the pack, in a sense, for many of these applications. The second one is that cost is going down. It was going down before, and it's keep going to get down. So I've noted the $60 per kilowatt hour. I'll hold you onto this, Achal, in 10 years' time. And the driver behind this is really the scale of production coming from the electric vehicle industry. There is also some geopolitical topics that can play a role in that, but it's mostly the main driver. And the third point is that there's a need for top-down support and government support, and actually across different topics. So we talked about revenue, but we talked about also recycling standards, safety standards. So there are different angles where governments can play a role and help batteries develop. Thanks everyone for this battery topic, and I will